Hello, everybody. Welcome to Chapter 5. We're in the skeletal system. This is our second organ system. And when you think about the skeletal system, a lot of times people think, well, that's the bones. Bones aren't living, but bones are living tissue. They are hard, but they are also living. They have blood vessels that run through them, and they have nerves. So if you've ever broken a bone, you know they have nerves because you felt the pain. And the swelling at the site shows that they have blood vessels. Bone is living tissue. Um, it continues to grow and develop in children until we reach adulthood, and then it still reproduces itself. So we're constantly producing new bones. So our skeletal system, the skeleton that we have now, is not the same skeleton we had when we were first born. So our bones are always producing healthier, stronger bones for ourselves and getting rid of the bad stuff. So this is just a figure from my OpenStax textbook showing fossils. Bone is hard, so it is a hard tissue, which means that it can fossilize. So there are lots of parts of the skeletal system. Remember, it's an organ system, so it's going to have more than just bone. We have bones, we have cartilage, both hyaline cartilage and fibrocartilage. We have ligaments that are composed of dense regular connective tissue. Remember, both cartilage and ligaments are not vascular, so therefore they don't heal very effectively. And then we have two different subdivisions of the skeletal system. We have the axial region and the appendicular region. When bones come together, they come together at regions called joints. So this is where two bones articulate together. So functions of the skeletal system. The first function, the most common and probably everybody's most obvious function, is that it provides support. So it gives us a shape for our body and supports that shape. So it is our skeleton. It's an internal skeleton. It protects underlying organs. So here we have that cranial cavity, and there underneath is the brain, a soft tissue that needs more protection. So that cranial cavity gives that protection. It facilitates movement. These are backwards, sorry. So when you are exercising and you're moving, when you're exercising, you're moving your bones, and it's because we have those bones, we have skeletal muscle attached to those bones that we are allowed to move. If the skeletal muscle didn't have bones to attach to, then we wouldn't be able to do the things that we do today. We store fat. So right here, yellow bone marrow is where we store fats. And fat is mainly adipose connective tissue, so it's like energy storage. In infants and young children, we do not have this yellow bone marrow. We only have red bone marrow. And it's the site of hematopoiesis. Hematopoiesis is blood cell formation. So it starts with this hemocytoblast up here that will then differentiate into a lot of different red blood cells. This is a bad picture, I apologize. But you can see those cells over here as well. Some of those cells become erythrocytes or red blood cells. That's what these are. Some become macrophages. Is that the macrophage? No. That's probably a neutrophil, I guess, then. So this would be a neutrophil, yep, and you can see it right there. It's just super large. I'm used to the large ones being the macrophages, but there is no macrophage on here. Macrophages would be even bigger than these. And then you can see even some platelets in here. So in an adult skeleton, we have 206 bones, and that is an approximation. Everyone has those 206 bones. Some may have a few more, but that's a story for another day. If you're ever interested, I can talk about that outside of this class. There are two types of bone tissue that make up all these bones, compact bone and then spongy bone. Compact bone is dense, and spongy bone is more opened. It looks almost like a bunch of little spicules, so needle-looking structures that make up that bone. And there's a lot of open spaces in spongy bone. Here's spongy bone right there, and then you can see compact bone there and there. So super, super strong, hard, compact, and then much more open with a lot of open spaces here for that spongy bone. Compact bone and spongy bone are both needed to make up our skeleton. So we can't just have compact bone only or spongy bone only. Bones are classified by their shape. So we have bones that are called long bones. They are longer in length than they are in width. We have short bones that are equal roughly in length and width. We have flat bones that are super flat, and they're usually slightly curved. And then we have irregular bones. These are the bones that don't fit into the other categories. So here's an example of a long bone. All of our appendage bones in general are long bones. So I shouldn't say that's not really true. All of our arm and leg bones are long bones. So we have the humerus, the ulna, the radius. We have the femur, the tibia, the fibula. All of our digits are long bones. So these are also long bones, and our toes and stuff. Short bones down here are carpals. Our tarsals and our carpals are short bones. The patella are short bones. They're a special type of short bone, but they are short bones. Is there another? Those are the main ones. Flat bones, the cranial bones that make up the cranium, those are all flat bones. Our sternum is a flat bone. Our ribs are flat bones. And then irregular bones, these are the bones that don't fit into those categories. Our vertebrae, our ilium, ischium, and pubis form the coxal bone, and that is also considered an irregular bone. So long bones, I just mentioned this, but we'll go over it really quick again, are longer than they are wide. They typically have a long shaft, and at the ends they have bulbous ends on each side. The shaft itself is compact bone, but the ends of the bone typically have spongy bone in them. Flat bones are very flat. They're curved, and they also have compact bone that surrounds a spongy bone inside. Short bones, carpals and tarsals, I mentioned that, and then your patella, which is a specialized bone called the sesamoid bone. These are short bones. They are, in general, close to the same length and width, and that's where they get that cube-like structure, and they're called short bones. They are also just have a thin layer of compact bone surrounding spongy bone in between. And then irregular bones, guess what? They also have a thin layer of compact bone with spongy bone in the middle. These don't fit into any other category. So they're called irregular bones, and the examples are your vertebrae and your coxal bones. This is just a concept link to remind you that we are looking at an organ system. Bones are organs, but other connective tissue is part of the skeletal system. So that includes fibrous connective tissue, like dense regular connective tissue, cartilage, adipose is found in those bones, and then we, of course, have blood and nerves that are in the bones. So let's look at long bone anatomy. Long bones look different. They have a different structure than your short, flat, and irregular bones, which all have similar structures. The long bone has a longer length than it does width. And when we look at a long bone, we have a region of the bone, the shaft of the bone is called the diaphysis of the bone. At the ends of each of these long bones, we have a region called the epiphyses. We have a proximal and a distal epiphysis. Proximal is closer to the point of attachment. Distal is farther away from that point of attachment. Surrounding the bone itself is a dense irregular connective tissue wrapping called a periosteum. And this is what brings in the blood vessels and nerves into the bone. The epiphysis, both proximal and distal, contain a lot of spongy bone, whereas the diaphysis is predominantly compact bone. Surrounding all spongy bone, we have a layer of compact bone around the edges, okay? At the proximal and distal epiphyses, we have a layer of articular cartilage. This is hyaline cartilage that allows bones to move past each other. So here where the bone is going to articulate with another bone, and down here where this region of the bone articulates with another bone, we have this cartilage that keeps the bones moving smoothly. It decreases friction, and so it decreases pain. In this region, we have a structure called the epiphyseal line. It would be on both sides. It starts out as a plate of hyaline cartilage, and as we grow, that plate gets smaller and smaller. So this is where growth occurs in bone. It's at that hyaline cartilage. We have bone growth occurring. And that's what allows us to get longer appendages to our body. Inside of the shaft, we have a hollowed out region called the medullary cavity. And in that medullary cavity, in adults, we have yellow bone marrow. Yellow bone marrow contains mainly fat. But if it was an infant or a young child, then this medullary cavity would contain red bone marrow. And red bone marrow is where blood cell formation occurs. So all of our blood is formed in red bone marrow. And in infants and children, we need to produce the our immune system. And we're also growing at a much more rapid rate. So we need more oxygen to those cells, stuff like that. And so we have to have more blood available. And here you can see, this is just a closer up picture, but you can see those Sharpie's fibers holding the periosteum to the actual compact bone. So we have all these bones, and bones have specific markings that help us to identify the different bones. I'm going to stop on this slide, and I'll start with this slide in our next video, okay?